All right, ready to untangle a bit of the everyday? Let's talk electrical wires. I mean, we see them everywhere, use them constantly, but how often do we really think about these things? Today, we're going to get shocked, metaphorically, of course, by just how complex these unsung heroes of the modern world really are.
It never ceases to amaze me.
Yeah.
Something so ordinary, right? But the backstory, the sheer engineering that goes into it, it's really remarkable once you peel back the layers.
And peeling back the layers is what we do best here.
Yeah.
And trust me, this one starts in a place most folks wouldn't last 5 minutes. Deep down in a copper mine.
Yeah, the source material doesn't sugarcoat it either. It's dark, it's dusty, heavy machinery everywhere. You've got miners working in these cramped tunnels using drills, explosives, all to extract the copper ore. Really puts a whole new spin on it's a dirty job, but somebody's got to do it.
Makes you appreciate that little charging cable a whole lot more, huh? But hold on, we're not talking just digging up copper and plugging it straight into the wall, are we?
Oh, not even close. That ore, straight out of the ground, full of impurities. It's like you wouldn't believe the transformation it has to go through. Multiple stages, chemical processes, heat. It's industrial scale alchemy. It's what it is.
All right, now you've got to break that down for us. How do we get from rocks in a hole to something that can actually carry electricity?
So first off, gotta crush that ore, grind it down super fine like powder. Then it's a whole dance of chemistry and heat. You're talking giant furnaces, liquids bubbling away, carefully controlled chaos almost.
Starting to sound a bit more sci-fi movie than factory here.
Right. And the source actually calls the molten copper liquid fire
Yeah.
at one point. Intense stuff. Eventually, though, it cools, solidifies, and boom, you've got pure copper.
So we've gone from rough chunks to what, like blocks of copper now? That what they make wires out of?
Well, you're getting warmer,
Yeah.
but those blocks are still, blocks. Got to get them way thinner, more workable. And that's where the magic, and I'm not exaggerating, the magic of wire drawing comes in.
Yeah.
Ever used one of those pasta makers?
Who hasn't? Though, full disclosure, I'm more of a buy the pasta pre-made kind of cook.
Right. But picture this. That pasta maker, except instead of dough, it's solid copper.
Yeah.
And those dies, the things that shape it, incredibly hard, precise, squeezing that copper down thinner and thinner.
So just like brute force squeezing it down to the right size sounds like a heck of a lot of pressure.
Oh, you have no idea.
Yeah.
Source says they're talking tens of thousands of pounds per square inch, easy. And it's not just squeezing willy-nilly. It's calibrated to get the exact thickness they need.
Man, this is already way more complex than I ever imagined.
Oh, we're just scratching the surface. Because that thin copper wire, it's basically a danger noodle without insulation.
Okay, yeah, insulation, that's going to be important. I mean, frayed cords, warning labels, we all know it's bad news. But what's the big deal? Why is it so crucial?
Safety, mostly.
Yeah.
Electricity, it's kind of lazy, it wants the easiest path to the ground, always.
So, like, if I touch a live wire, it's going to use ME as that shortcut?
Lovely. Pretty much. And that's where our friend insulation steps in. Creates that barrier, stops you from getting zapped.
Yeah.
A&D, way more importantly, stops the electricity from going rogue, causing fires, short circuits, the whole shebang.
So it's not just personal safety, it's preventing electrical chaos on a grander scale.
You got it. And here's where it gets even more interesting, and the source digs into this. Picking the right insulation. It's not just slap some plastic on it and call it a day.
Oh, I bet. So many different kinds of wires out there. What kind of materials are we even talking about?
The usual suspects are plastics, PVC is a big one, thermoplastic, stuff like that. Or sometimes rubbery materials. Flexible, tough, graded, blocking the current. Perfect for your everyday wiring.
Makes sense. But those high temp wires, the ones you mentioned earlier.
You remember.
Yeah.
Yeah, for something like a jet engine, that's a whole nother ballgame.
Because, melting wires probably bad for the whole flying thing.
Slight understatement. You need stuff that laughs at heat. Nickel alloys, even ceramic composites sometimes. Those can handle temperatures that would turn regular wiring into, well, not wire anymore.
So high-tech insulation for the high-tech wires. Makes sense. Okay, so insulated copper, we're good to go. Right. What's next on the wire-making greatest hits list?
Hold your horses. One more crucial detail, often overlooked. Color coding.
Ah, yeah, the rainbow of wires. Always wondered about that. Can't just be for looks, right?
Nope, not about aesthetics. It's about keeping things organized and safe, especially for the electricians who work with this stuff day in, day out.
So like a visual language for wires.
Exactly. Imagine you're staring at a spaghetti junction of wires. Without that color code, you'd be testing each one individually to figure out what's what.
Sounds time-consuming at best, terrifyingly dangerous at worst.
Bingo. Color coding. It's simple but brilliant. Each color, it's got a job, a meaning. Electricians know instantly what they're dealing with, no guessing games, no accidental fireworks displays.
Okay, give me the SparkNotes version. Green wire, red wire, what's the deal?
All right, so U.S. system, the most common one, green's your grounding wire, white or gray is neutral, black's the hot one carrying the juice, and sometimes you'll see red for a second hot wire in certain setups.
So glance at the color, you know the job, you know how to stay safe. Simple, but effective.
Exactly. And speaking of safety, can't forget about the unsung heroes of the wire world. The quality control folks, they're the ones making sure these things are actually, functional.
Right. One bad wire could mess up the whole system. Like my grandma always said, a chain's only as strong as its weakest link. And I don't think she was talking electrical engineering at the time, but...
But it applies. And the source, it hammers this home.
Hmm.
Quality control, it's not an afterthought. It's woven into the whole process.
So what are they doing? Give us the rundown. How do you test a wire?
Well, first off, got to make sure it can actually conduct electricity, right?
It seems important.
They'll test conductivity, making sure it can carry the right amount of current without, turning into a fuse itself. Then there's tensile strength. Got to make sure it can handle being bent, pulled, generally manhandled during installation.
So like a wire obstacle course.
Basically. And then, of course, got to put that insulation through the ringer, make sure there are no weak spots, no leaks waiting to happen.
So it's all about anticipating problems before they start. I never realized how much goes into making something I just, assume is going to work.
That's the thing with everyday stuff, right? We take it for granted. But this is just your average wire we're talking about. The source mentions some truly wild stuff, wires designed for, extreme conditions.
Oh, like what? Do tell.
Think inside a jet engine? Temperatures up the wazoo.
Yeah, I'm going to go out on a limb and say your average rubber coating ain't going to cut it there.
Not unless you want melted goo all over your high-tech engine parts. No, we're talking specialized stuff. Nickel alloys, sometimes even ceramic composites for the insulation. Stuff that laughs in the face of heat that would turn regular wires into, well, not wires anymore.
Talk about heavy duty. So it's not just the wires themselves, it's the insulation that has to be tough as nails too.
You got it. And heat's not the only challenge out there. How about underwater? Now those wires, those got a story to tell.
Oh yeah, those deep sea internet cables, right. Talk about pressure, literally and figuratively.
And then some. Those cables, they're like engineering masterpieces, layers upon layers of protection. Got to keep saltwater out, obviously, but also deal with the pressure down there, avoid getting tromped on by curious sea life.
Like giving a wire its own little wetsuit and a suit of armor, all in one. Makes you realize all that stuff we take for granted, just plugging in our laptops, it relies on some seriously hardcore tech.
It really does. And hey, speaking of unsung heroes, got to give a shout out to the electricians out there, the ones who take all these wires, fancy and not so fancy, and actually, make them work.
Right. We've talked about the mines, the factories, but it's the electricians on the front lines making sure those electrons flow where they're supposed to.
Exactly. Reading those blueprints, working in cramped spaces, making the connections that literally keep our world running. It's a big deal.
No kidding. It's like they're conducting a symphony, but instead of music, it's electricity, and nobody wants to hear those instruments clash.
Right. And most of us, we don't even think about it until the lights go out or the Wi-Fi drops. But that complex web of wires, the people who keep it all humming along, major props to them.
You know what? This whole deep dive, it's really opened my eyes. Every time I flick on a light switch now, it's going to be a whole new experience. From the mine to the factory to those electricians, it's all connected.
That's the beauty of it, right? You start digging into these everyday things and you find a whole hidden world of complexity and ingenuity. It's pretty amazing when you think about it.
Totally agree. So, to everyone listening, next time you encounter something you think is boring, take a second look. You might just be surprised at the journey it took to get there. And that's a wrap on this electrifying deep dive into the world of electrical wires.